Status check. Propellants.
Go Atlas.
Go center.
Go center.
Pressurization.
Go Atlas.
Go center.
Atlas Autopilot.
Go.
Centaur Autopilot.
Go.
Launch Director.
Go.
Memorial Day, May 30, 1966, Cape Kennedy, Florida.
All recorders fast.
Minus 12 seconds.
Engine start.
Minus 5, 4, 3, 2, 1. I release.
The Convair-built Atlas 290D and Centaur 10 successfully boost the spacecraft Surveyor 1 into a lunar intercept trajectory. Surveyor 1 soft lands on the moon. Its television cameras photograph and transmit to Earth the first pictures from the surface of the moon. They prove that man and his equipment can be safely landed there to begin the new era of exploration into the outer reaches of space. Another era began 44 years ago when Major Reuben Hollis Fleet leased the facilities of the Gallaudet Aircraft Corporation in East Greenwich, Rhode Island, to build airplanes. Interviewed in 1953 on the occasion of Convair's 30th anniversary, Major Fleet gave this account of Convair's beginning.
I had just resigned the Army Air Forces and had taken a contract as a manager of Gallaudet Company. To my surprise, I found that it had nothing worthy of continuity or perpetuity, and that it owed $3 million. So I decided to get a new start. I founded Consolidated Aircraft Corporation with $25,000, which my sister and I put up. I bought the designs from the Dayton Wright Company to the TW3, which is a side-by-side trainer. I got a contract for 20 of them from the Army, amounting to $180,000. I finished the 20, and meantime concluded that the airplane was not a success. But at the end of the contract, we had $201.98 profit.
$201.98. Not even enough to fuel one of today's jet aircraft to fly from San Diego to San Francisco. From this beginning grew one of the world's largest corporations. Typical of what we term American determination and drive, Major Fleet and his fledgling Consolidated Aircraft Corporation was to forge ahead and within a few short years outproduce the world in airframes of all types. Successful demonstration of the prototype of an improved trainer designated PT-1 resulted in a large order from the Army. Needing better facilities, Consolidated moved to Buffalo, New York in 1924, where production of the PT-1 and the Navy version NY-1 continued as their fame spread to 22 foreign nations. Safety and rugged dependability were synonymous with Consolidated aircraft. A variety of land and water-based aircraft were to follow these early planes. The company's first flying boat, the PY-1 Admiral, from which later evolved the 32-passenger water-based Commodore. Later came the P-2Y series of flying boats. And the world-renowned PBY Catalina patrol bombers. Prompted by an ever-increasing need for year-round testing and flying seaplanes, Consolidated moved to San Diego, California in the fall of 1935. In San Diego, Consolidated prospered and was soon employing thousands of people. As war clouds loomed over Europe in 1939, the Air Force ordered a 4-engine heavy bomber. Designed and test-flown less than 9 months from the mock-up completion, the B-24 Liberator bomber was in its day considered to be one of the greatest pieces of machinery ever to be mass-produced. The earliest Liberators went into combat with the Royal Air Force of Great Britain. The LB-30s, as they were designated, were ferried to England by American pilots. During World War II, Liberators were the most numerous heavy bombers on all the battlefronts of the world. Over 18,000 were built. Of these, Convair built over 11,000. Cargo transport versions were the C-87 Liberator Express for the U.S. Army and the PB-4Y privateer version for the Navy. As the demands of war dictated, numerous other aircraft designed for a variety of uses rolled off the Convair assembly lines. P-66 Pursuit, Valiant BT-13, PB-2Y Coronado, B-32 Dominator, Vengeance A-35, AT-19 Reliant. The 1943 merger of Consolidated and Vultee Aircraft Corporations brought together resources and facilities enabling the new Consolidated Vultee Aircraft Corporation to maintain a leading position in the industry. Emphasis on production of the B-24 and B-32 bombers temporarily delayed start of production of the world's largest bomber, the B-36, until late 1945. The giant B-36 planes were to evolve through various updating refinements as the big stick of the Strategic Air Command in maintaining the hard-won peace. It has been said that the B-36 was perhaps the greatest single deterrent to a World War III. Post-war requirements for military craft dwindled, but did not cease entirely. Convair developed a folding-wing single-engine liaison plane, the L-13. It was designed to get into and out of small areas for observation, communication, courier service, and many other uses not possible by larger, faster planes. The experimental XB-46 4-engine jet bomber and the world's largest cargo plane, XC-99, were introduced in 1947. This double-decked craft set cargo-carrying records during the Korean conflict. Commercial airlines were to log billions of passenger miles on all 6 of the world's continents with the Convair liner 240. These twin-engine, 40-passenger pressurized transports were built for use by more than a dozen airlines for medium and short-range traffic. Military versions went into service with the United States Air Force. The T-29 Navigator bombardier trainers were dubbed flying classrooms. Practical training while airborne, using the same type of equipment installed on combat planes, was to aid the Air Force in more rapidly molding flight crews to combat readiness. Convair's long list of reliable products are important to aviation's progress. Of equal importance are the innovations and firsts it has contributed to the industry. Ideas projected toward the distant future provide added new dimensions to aeronautical technology. Convair was first in the air with a delta-wing aircraft, the XF-92A, a delta-wing single-engine jet fighter. Successful results of this research program in 1948 were to become the F-102 series of all-weather, round-the-clock interceptors for the United States Air Force. Follow-on advancements produced the F-106 series. Experience in the use of turboprop engines dates back to 1943, and the XP-81, the first American plane ever flown with a turboprop engine. A series of pioneering firsts succeeded this accomplishment. A 4-engine turboprop patrol seaplane, the XP-5Y. The Convair 240 Allison turboliner. the turboprop seaplane transport, R3Y Tradewind. A twin-engine military transport, the Air Force, YC-131C. The delta-wing turboprop vertical takeoff fighter, XFY-1, nicknamed Pogo. The YB-60, a swept-wing 8-turbojet engine super bomber for the Air Force. Hydrodynamic research by Convair produced the world's first jet-powered delta-wing seaplane for the Navy, the XF-2Y-1 Sea Dart. In 1954, Consolidated Vultee Aircraft Corporation passed into history. A merger with General Dynamics Corporation resulted in the name Convair, becoming the official title for the new division of General Dynamics. The V-2 rockets used by Germany during the closing days of World War II made evident the fact that rockets were no longer the novel playthings of small groups of experimenters. In 1945, under an Air Force contract known as Project MX-774, Convair began a study of ballistic missiles. Defense cutbacks in 1947 literally shelved the project, except for limited research conducted by Convair. In 1951, the Korean War resulted in increased defense appropriations. Convair was awarded a contract under Project MX-1593 to study the merits of ballistic and glide rockets. The ballistic approach was selected as the one with the most potential. Experience gained on MX-774 was put to the test, and the Atlas program was underway. In 1955, the new Atlas program, designated WS-107A1, was given the highest national defense priority. By 1957, astronautics had been formed as a division of Convair to produce the Atlas. New facilities were constructed in San Diego. Less than 5 years were required for the largest, most complex production, testing, and flight program ever undertaken for the Atlas to become America's first operational intercontinental ballistic missile. Even while the giant missile was in production as a weapon of defense, astronautics was already engaged in seeking to advance man's knowledge of space. The reliable, flight-proven Atlas has a long and enviable history of successful achievements for both the Air Force and the National Aeronautics and Space Administration. Atlas played a significant role in Project Mercury, boosting our first astronauts into Earth orbits. One after another, Atlas missions have launched Ranger, Mariner, the Orbiting Astronomical Observatory, the Orbiting Geophysical Observatory, Project Fire, Agena targets for Project Gemini, Centaur Surveyor. The list continues to grow, and no immediate end is in sight for the reliable space booster Atlas. Convair in 1951 activated its Pomona division to produce new types of aerial weapons for the United States Navy Bureau of Ordnance. Pilot models of Convair's Terrier were produced in San Diego. By late 1953, these surface-to-air guided missiles were in production at the new Pomona facility. Another supersonic surface-to-air guided missile produced at Pomona is Tartar. A new standard missile for shipboard use is under development. Red Eye, a shoulder-fired surface-to-air missile, provides combat troops in the field with an effective weapon against low-flying, strafing, or bombing aircraft. Development of the Centaur was prompted by the nation's need for a high-energy second-stage space vehicle. Design concepts proven by the Atlas were employed in the production of Centaur. The program started contractually in late 1958. One of the major problems in its early development stage was that of taming and handling the liquid hydrogen used as fuel for the vehicle. By 1965, with the final research and development flight of a single burn Centaur, AC-6, the vehicle was considered operational. The flight of Atlas Centaur 10 Surveyor 1 fully justified NASA's and Convair's faith in the vehicle. Beyond Centaur Surveyor lunar flights, other missions are in the planning stage for Centaur. While its space-age projects were developing at a rapid pace, Convair was still moving forward with some of its original programs and beginning new ones. With air travel increasing, the demand for transport planes was greater than ever. Based on the design of the service-proven Convair 240, a larger version came off the assembly lines. The 340 Convair liner. The Military Air Transport Service utilized a version called the C-131A Samaritans as air evacuation hospital transports. A modified version of the 340 liner, designated R4Y1, was in service with the U.S. Navy as personnel transports. Followed by still another model, the 440. By now, nearly 30 airlines around the world were using the family of Convair liners. Convair Fort Worth Division produced the B-58 Hustler, the world's first supersonic bombers. These are in service with the Strategic Air Command. Air Force crews have set 19 world flying records with the B-58. Keeping pace with the expanding jet age, Convair produced the 880 Transport. This craft can accommodate between 88 and 110 passengers, depending upon the seating arrangements. Convair's 990 jet airliner was designed for operation at near sonic speeds. The 880 and 990 were called pilots' airplanes. Both are serving domestic and international airlines. 2 years of development and testing were conducted on a prototype counterinsurgency aircraft called Charger. Its capability for short takeoff and landing and its ability to operate as a close-in support plane in difficult terrain was clearly demonstrated. An unfortunate crash destroyed the plane. However, data obtained during the flight tests clearly indicated a useful potential for such an aircraft. Of nearly 1,100 Convair liners produced since 1946 for both commercial and military transport use, over 1,000 are still in service around the world. Over 20 years of unquestioned proof attesting to the rugged dependability of aviation's most reliable airframe. In support of these aircraft, Convair initiated a modification program for the 240, 340, and 440 liners. Replacing the reciprocating power plants with Rolls-Royce Dart turboprop engines and refurbishing the planes throughout will keep the new Convair 600 series the leader in the field of short and medium-range transports. With its long history of proven high standards and quality workmanship, Convair is engaged in numerous large subcontracts. From Lockheed, Georgia, the 63-foot-high complete tail assembly for the Air Force C-5A, the world's largest jet transport, and the complete empennage section for the C-141, heavy logistics transport. For the Air Force, updating modifications to the F-106 and F-102 interceptors. For the F-111 Air Force and Navy variable wing fighter aircraft, Convair is fabricating the stabilizer boom structures and the redesigned fuel tanks and pylons. A Douglas aircraft contract provides for Convair to fabricate door and jam sections for the DC-9 transports. Mark 56 non-magnetic mine cases for the Navy. Under contract to Kaiser Aluminum for the United States Army Corps of Engineers, lightweight transportable landing mats are in production. These mats make it possible to rapidly lay landing strips in areas where conventional airfields would be difficult, if not impossible, to construct. A variety of other contracts and engineering studies are also underway. Inherent with America's space effort, man's safety in flight is a prime requisite. For Project Mercury, Convair developed its own abort-sensing instrumentation system called As-Is. For Apollo, Convair produced Little Joe 2, a simple, reliable, solid-propelled launch vehicle. Capable of thrusts ranging from 300,000 to 720,000 pounds for short periods of time, Little Joe 2 launched low-level ballistic test flights of the Apollo moonship abort system. Not all of Convair's efforts are in the fields of aviation and space technology. The science of oceanography offered new challenges. An unmanned ocean data station was developed by Convair for the United States Navy Office of Naval Research. Primary task for this 100-ton, 40-foot diameter buoy is to transmit via telemetry oceanographic and meteorological data to shore stations. Equipped to collect, store, and transmit large amounts of information, the buoy is designed to operate in any ice-free waters of the world. When operational, it will be an important tool for both scientific knowledge and long-range weather prediction. Equipped with beacon lights, fog signals, and a radio beacon, it will also serve as a major aid to marine navigation. From its beginning as a leader in the aircraft industry, Convair has not only kept pace with scientific advances and new technologies, but has in many instances set the pace. From giant bombers to miniaturized circuitry, from intercontinental missiles to life support systems, the Convair story is one of product and people, and the future of both.
A champion is always news. But being a champion means more than headlines in the papers. It means that in terms of performance and accomplishment, the efforts of one are proven superior to the efforts of all others combined. And if by chance we could personally meet those who know the champions best, we'd probably want to ask the same basic question that most people would. How did they achieve their eminent position and success? Our story is the answer to that question. There's been a lot of talk about speed, but there can only be one fastest jetliner, only one speed champion. On its delivery flight, Delta's first Convair 880 became that champion, setting an ocean-to-ocean transcontinental record with an average speed of 665 miles per hour. But speed is only one facet of performance, and there are many ways to look at a champion in order to find out the many interesting things you want to know. Take an airline captain with 20 years' experience. His introduction is filled with technical details. How does she handle? How does she perform? That's what he wants to know. And the answer is as smooth as silk. On the ground, aircraft engineers and maintenance crews look at it from a different point of view. The trim, sleek lines, the sweep back of the sturdy wings are to them symbols of integrity, an integrity of concept, design, and structure. Looking more closely at the structure is, in a way, a preview of the 880's whisper-quiet cabin. Part of that quiet you can credit to the use of a thicker outer skin, in keeping with the principle of integrity of design. Silent flight is engineered into an airplane's cabin. It can be accomplished by using a heavy aluminum foil sandwich with a special plastic backing. Then, over it, apply thick blankets of fiberglass insulation. Now add triple panel windows with air spaces in between. And then round out the quiet engineering with a floating inner shell of panels that help exclude or help absorb nearly every bit of sound. And also credit a big assist from the powerful General Electric pure jet engines. The smooth turning turbines and compressors mean dependable vibration-free performance. And the integral sound suppressor, a daisy petal-shaped exhaust outlet, provides a tremendous reduction in sound level. But technical details are only a preliminary briefing to a more personal introduction to the jetliners with the fastest scheduled time of any jetliner, the one they call the quietest distance between any two cities. And ask Jim Thompson. A call between two cities can be interesting too.
Hi, honey.
Hi.
Everything's done. I finished the meeting sooner than I expected, and I'm on a Delta 880 flight, so we'll have dinner together.
Oh, I have to get my hair fixed before I pick you up.
You won't have time, dear. We're leaving in a few minutes, and the way traffic is, you'll have to start within half an hour.
Jim Thompson is explaining to his wife a present-day fact of life. With jet speed being what it is, most of us have to figure that it can take longer to go to and from the airport than it takes to travel 1,000 miles in the roomy cabin of your 880 jetliner. Forward of the main cabin is the club compartment. And as you relax back in your seat, you are ready for the wonder of your introduction aboard the fastest jetliner in the world. In that intimate but spacious club compartment, there is no speed sensation. The only sound you hear is from the air that is slipping by outside. The hum of friendly conversation is much the same as in your living room. And just the way it is at home. Don't let a member of the family give you too much good advice.
As a stewardess, I've served on a lot of different kinds of airplanes. But no plane has ever had the same appeal to passengers that these new 880s seem to have. Maybe it's because racks overhead are easier to reach. And maybe it's the special air conditioning that gives a uniform and pleasant climate anywhere they're sitting. Maybe it's because there's a certain home-like feeling in the cabin. But I guess it doesn't matter what the reasons are. The main thing is that all my passengers enjoy every minute they're on board. If there's work to do or just relaxing, time seems to float right by, so quickly, quietly, and so very pleasantly that anyone can rest without ever getting restless, even the very youngest generation. When we're on between-meal flights, many of our guests get added pleasure from a tasty snack. And, if they like, the cocktail of their choice, to sort of tide them over till they reach their destination. Of course, dinner time for some can be absolutely any time, and we tide those folks over too. Everything does seem easier when you can fly 1,000 miles in less than 100 minutes. Pure white, pure jet, pure luxury. And Mr. Thompson can't help wondering if his wife has run into some of the usual heavy highway traffic that might hold her back from arriving at the airport in time to meet his 880 that's already coming in to land. From way up north to way down south, people at the airports can recognize our 880s by their streamlined look and that pure porcelain white finish. But the passengers who fly on them can tell by 101 little things that one way or another, the speed and comfort of the fastest planes add much more than just a time advantage to their vacation or their business travel. And as a stewardess, you get to understand why parents find it easier to fly, or how much passengers appreciate thoughtful service and consideration on the ground as well as in the air. And you know why Mr. Thompson asked his wife to start out early when meeting his 880. Every year I travel almost 500,000 miles between a score of different cities, and one good thing is always true. Whether your passengers are 100,000 milers or if they're on their very first 880 flight, they all seem to feel instinctively that they're flying with a champion, and it's a feeling that they like.
At day's end, twilight sunshine seems to last a little longer in the sky. And cabin lighting, indirect, flows softly from behind the sculptured panels overhead. It's a pleasant time to travel because you know that in more than just a general way of speaking, you've almost reached your destination when your 880 leaves the ground. It's only natural for a youngster to take a lot of things for granted that those who've been around a little longer can appreciate more fully. For a man whose type of business can keep him on the go, speed has an extra special meaning that only those who travel often can truly understand. Evening time is mealtime, too, and Royal Jet Service hospitality adds a certain flair to dining that makes you feel you're glad your appetite is healthy. And anyway, tomorrow is a better day on which to start the diet you made yourself a promise you would surely start today. There are 3 stewardesses aboard and twin buffets installed at each end of the cabin to help make the service even better. But here in the quiet of the cabin, there is no need for haste, although the world below is speeding by more than 10 miles in every minute. And there is one more thing to know about this champion of the airways, perhaps the one thing with the greatest meaning and most personal appeal. Because of its ability to fly in and out of intermediate-sized airports, the 880 will bring the benefits of jet travel to people sooner than they could be served by other jetliners. And therefore, to many people, in many places, the 880 is opening the door to the wonders of jet flight that have made travel by air today the most satisfying way of travel that we have ever known.
During the period of October 1957 through April 15, 1958, the Convair 880 commercial jet airliner began major component construction. Many subcontractors and vendors, contributing parts and subassemblies from all over the country, began making deliveries. The 880 program moved into full swing as the first production model of Convair's commercial jet airliner program was scheduled for test flights early in 1959. Significant in the period leading to this report was the construction of a complete metal mock-up in 880 tooling jigs, a metal mock-up that is being used to finalize all tubing, harness, and interior installations well ahead of production schedules. The swept-wing Convair 880 will be capable of operating from all airports throughout the world, now handling 4-engine piston aircraft. The ruggedly built Convair 880 was specifically designed for economical medium and short-range operation. But with the addition of the wing center section fuel system, it converts to a highly efficient long-range liner. In any range, the 880 is designed to provide the finest in passenger and operational services. 2 plug-type doors are located at each end of the fuselage for easier passenger handling. Opening or closing can be accomplished by the stewardess with a minimum effort. When the door is pulled to the fuselage, it slides downward and wedges into place and is safely secured in one simple motion. The interior features unique appointments in every detail of comfort and convenience. Standard seating arrangements will accommodate 88 passengers in luxury flights and 109 in the coach configuration. An airline crew can convert first class to coach in a few hours. The high safety qualities incorporated in the new dual window arrangement offer each passenger his own private viewing area. The 880 air conditioning system was developed and tested as a part of the 880 test program. 44 general outlets, along with 109 individual passenger outlets, supply a complete change of fresh temperature-controlled air every 2.5 minutes in the passenger area and every minute in the smaller flight deck spaces. The 2 galleys have been compactly designed for efficient service. The spaciousness of the 880 cabin allows for more comfortable passenger seating arrangements than ever before possible. The advanced designs in 880 cockpit lighting eliminate distracting reflections and keep the instruments in the cockpit area glare-free. The glare shield keeps the windshield free from instrument panel reflections. White and red dimmable floodlights are used to eliminate the tunnel effect created by the shield. Similar floodlighting is available throughout the cockpit. The new use of printed circuitry makes each panel more compact and increases the effectiveness of the new improved dimmable edge lighting. The lighting designs incorporated in the flight engineer's panel simplify the operation of the 880's systems. In the newly constructed Convair Acoustics Laboratory, extensive sound testing has been conducted to determine the best material to be used in soundproofing the 880 cabin. The material to be tested is installed in the window separating a live room from the completely soundproofed room on the other side. In the adjoining soundproofed room, sound readings are taken. Over 100 materials have been tested in this way to determine the best possible soundproofing material to be used in subduing jet engine and aerodynamic sounds in the cabin area. On the outside of the metal fuselage section here in the large reverberation room, sound levels simulating the noise produced by the 880 engines have been established. Acoustic tests are first conducted on the bare metal fuselage section, and then different layers of soundproofing materials are added in a series of build-ups with tests in each stage. This is continued until a full-scale cabin mock-up has been completed and tested. Then furnishings are removed, testing is completed, and a final soundproof configuration established. In the General Electric plant in Evandale, Ohio, the CJ805 engines, 4 of which power the 880, are being manufactured. The military version of this engine is being used in the Convair-built B-58 Hustler, the world's fastest bomber. The Minnesota Mining and Manufacturing Company in St. Paul, Minnesota, contributed to the success of the Convair-developed manufacturing process called Scotch weld. This is a process that combines added structural strength with a greater fuel tank integrity, making possible the maintenance-free integral fuel tank. This design permits the use of the interspar box structure as a fuel container and gives maximum range with minimum maintenance. The Scotch weld tank has not developed a single case of fuel leakage in over 4 years of rugged military use in hundreds of F-102 and F-106 interceptors. The Scotch weld process begins in the cleaning baths built especially for the construction of the 880 at a cost of over $500,000. In the cleaning bath area, the parts to be Scotch welded are cleaned, chemically treated in special tanks, oven dried, Scotch weld primed, and force dried in the curing oven. In the assembly area, the Scotch weld adhesive film with its protective backing is applied over the drilled sections where metal is to be joined to metal and drilled to match the holes in the metal sections to be assembled. The protective backing is then pulled away, leaving the translucent Scotch weld film in place, and the fuel-tight rivets are driven. The completed wing assemblies are brought to the giant 880 oven built especially for final 880 wing curing. The $175,000 oven installation was thoroughly tested using a pair of R3Y wings similar in size to those of the jetliner. Once the oven curing is completed, the wings are ready for mating. At Convair's structural test jig, the Scotch weld system is once again tested in an 880 wing section. The purpose is to demonstrate the fuel-tight integrity of the Scotch weld integral wing fuel tank by load cycling under pressure and adverse temperature conditions. Testing is done at temperatures ranging from 65 degrees Fahrenheit below zero to 160 degrees Fahrenheit above. Internal pressures range from 3 to 10 pounds per square inch. External load cycling pressures exceed 13,000 pounds. Medium-range transport aircraft are subjected to more strenuous punishment than long-range transports, and these highly successful tests have subjected the 880 wing to stresses far in excess of those that will be encountered in normal operation. No fuel leaks have occurred in any test conducted. The last of the famous Convair 440 liners, in service throughout the world, reached the end of their assembly line as the earlier phases of the 880 tooling program began. With the completion of the highly successful Convair liner program, over 1 million square feet of floor space became available for the production of 880s. The near-sonic speeds of the 880 require a higher degree of precision construction than ever necessary in the slower commercial airliners of the piston era. Pioneered by Convair in supersonic F-102 and F-106 interceptor construction, optically aligned tooling jigs are used to build the 880. A revolutionary new tooling method that makes possible the highest degree of accuracy in aircraft precision construction to date. Optical tooling means simply that large fixtures are constructed along lines and angles that are established optically. From this basic principle, a jig big enough to assemble a complete 880 wing can be aligned for construction. An alignment telescope is precision mounted on one end of the jig. An illuminated target is precision mounted on the opposite end of the jig. Facility gauges or locators are added, in which bullseye targets can be inserted and positioned in strategic locations along the frame to be aligned optically so that a basic precision line of sight is established on which the wing buck will be built. This fundamental procedure is continued through all necessary angles until the tooling jig is completely aligned, and on which an 880 wing can be assembled with precision accuracy. Periodic checks are made to ensure that the jig remains true, and construction becomes a matter of basically clamping parts to the pattern and riveting them until the wing is finished. Approximately 30,000 structural parts needed for a single 880 are meeting regular production schedules. Cover plates, forgings, channels, sump castings, landing gear mechanisms, ducts, fuselage skins. The world's largest radial draw former, built to Convair specifications at a cost of $800,000, is one of the many special installations added to the 880 production line. A tremendous pressure of 75 tons is applied by the draw forming machine to raw stock, and in a single movement, one of the huge fuselage belt frame sections is formed and ready for assembly. In the spar mill area, 3 different size spar mills are being used in the manufacture of 880 wing spars. A 30-foot mill, a 66-foot mill, and the 108-foot Onsrud, installed for milling the larger 880 wing spars. The spar rails are fitted to optically aligned jigs on the spar tables, and webs and stiffeners are added, drilled on the new automatic gantry-mounted drill, and riveted. The individual spar sections are then moved to the optically aligned vertical tooling jigs, where the 2 sections making up a completed spar are joined and the pylon fittings added. When the spar has been completed in the vertical jigs, it is ready for the major wing assembly. In the wing skin and stringer panel optically aligned jigs, the wing panel sections are being constructed. The stringers are fitted and clamped to the tooling pattern. The wing skins are then lowered to the tooling jig and fitted to the stringers, and riveted, and the wing panel is completed. In production areas throughout Convair San Diego Plant 1, the major components of the 880 are now meeting production schedules. From the earliest test stages through more advanced testing, the 880 has moved steadily toward full-scale production. Huge equipment installations have been designed and installed. The thousands of small parts used in the liner are meeting weekly production schedules. The first flying version of the 880 is now under construction and will be the first of a full-scale production program aimed at producing 6 Convair jetliners each month. The 880 has grown from an idea into production and is moving steadily toward the first test flights scheduled for early in 1959. Here now is Mr. Sandy Cogan, Convair Vice President and San Diego Division Manager.
What you have just seen represents the progress we here at Convair have made in developing a commercial transport that will answer the needs of airlines for many years to come. In the past, we have shown you the extensive test and development programs that have been in progress for over a year. Now you have seen the immense production program currently producing the 880 jet airliner. From this beginning, 880 manufacture is moving toward a full-scale program capable of supplying airlines all over the world with Convair jet airliners beginning early in 1960. Able to land in over 335 cities throughout the United States, Canada, and Hawaii, the 880 is the only airplane initially designed for the rugged demands of medium-range service. Typical of some of the routes the 880 can service: Chicago to Kansas City, 405 miles. Kansas City to Los Angeles, 1,368 miles. Los Angeles to Seattle, 964 miles. And of course, cross-country, San Francisco to New York, non-stop, a distance of 2,580 miles. Although designed for medium-range service, the versatile 880 will economically fly routes as short as 250 miles, or, with the addition of the wing's center section fuel system, non-stop routes as long as 3,250 miles. This means that the 880, purchased for medium-range work, can be used by an airline to supplement larger jets on long-range flights, and it will do so at less than two-thirds the cost involved in operating the larger ships. The extra speed, combined with the fact that it is the only jet transport initially designed to operate economically with a deluxe 4-abreast seating arrangement, virtually assures that passengers will prefer to fly in the 880. The 880 will fly 615 miles per hour, making it the world's fastest airliner, faster than any competing jet transport by a substantial margin. This extra speed, combined with a turnaround period of only 25 minutes, gives the 880 an excellent work capacity. For instance, the 880 cuts almost 40% off the time required for current aircraft to make the trip from Chicago to Los Angeles. The trip now requires 5 hours and 24 minutes. The 880 will fly it in 3 hours and 25 minutes. This speed advantage and the rugged construction of the 880 means longer first-line life than has ever been realized in the past with piston engine aircraft. It will be first-line equipment for at least 12 to 15 years, and in some cases, as much as 20 years service will be realized on the routes for which it was initially purchased. On a 1,000-mile trip, the 880 need carry only 34 passengers to cover the total cost of operation. Conservatively then, a 60% annual load factor on a 1,000-mile run, such as New York to Miami, would earn an airline $2,125,000 a year, based on a 10-year depreciation. Forecasts show that airline traffic in the U.S. will more than double by 1965. Traffic that will require jets like the 880. Convair is proud to announce that the tempo of production is increasing daily. The first 880 will fly early in 1959, and we at Convair are confident that the 880 will be the finest and safest in jet air travel.